Hello, everybody. I like to see some familiar faces. Thanks for joining. I'll just get right to it, I guess. Let's power through. I think I'm not going to need 60 minutes for this presentation, depending on your involvement, I will say. My name is Joerg. I'm an Austrian. I've been living in Germany for quite some time now. I've been doing software for a living for a long time. I had my first contact, my first encounter with LabVIEW in 2007, which is also quite some time ago. And the company that I'm working with right now, Hampel Software Engineering, I started that around 2015, 2016. And we are the first NI Center of Excellence in Germany. I'm quite proud of that. I might or might not talk about that a little more later on. And I like working in small teams. I like working with people. I like talking to people, with people. I like presenting, of course. And my whole business is revolving around working in teams. Seeing as we're in Germany, in Europe, we used to do a lot of fixed price work because that was the way that work is done there. It has eased up a little bit recently, so we're also having T&M projects recently. I'm a sucker for process workflow standardization and automation. We might have a chance to go on a tangent on that, maybe. And I do a lot of inner source and open source work with and in LabVIEW, so I'm very happy with things that are happening recently. Thanks, Sergio. Kudos to that. You see lots of colored pictures here. I do a lot of stuff. I try to be very present in the community. What stands out maybe is that I am on the board of directors for the DQMH consortium. So I personally have a very invested position in DQMH, so I might be a little biased when I'm saying it's the best framework and it's the only framework you should use. I still stand by that, but your mileage might vary, of course. So take it with a grain of salt, maybe. Our slogan is create better software. Like I said, we work with our customers. We integrate with our customers. Usually, those are engineers. They are not necessarily computer scientists or had any form of proper training in computer science. They are experts in their own domains, like maybe physics or chemistry, electrical engineering, whatever it is. But usually they have to use software as part of their job. And that's where we come in, and we help them make their lives easier and get their work done in a nice way. Today, we're going to talk about the DQMH Generic Networking Modules. A quick show of hands maybe, who is familiar with a DQMH? Okay, so a little more than half of the room, I guess.
I don't know what that is. I'm teaching her.
So for those of you who are not so familiar with either DQMH or the history, we have Fab here, Fabiola de la Cueva. Please get up. She's the founder and lead architect for DQMH. Delacor, her company, used to run DQMH before it graduated into being maintained by a consortium. I'm going to get back to that later on. And where is this? First of all, it's available already. This is part of our open source modules that we are providing to the community, that we are using in our projects. So if you want to go and just use it, here are the QR codes for both the source code and the documentation. Documentation leads you to our DQMH Wiki platform. Source code leads you to vipm.io, where you can install this package together with all the dependencies quite easily through the VI package manager. Okay, so where does this all come from? What is this all about? The original problem statement that actually dates back maybe 15 years, so long before I worked with DQMH and even before DQMH was actually published. The original problem statement was, how do I talk to my RT targets from my Windows PC or the other way around? So we still are doing a lot of work on distributed systems. And it always begs the question, okay, how do you do that? You have your real-time target, you have your Windows PC. Maybe you have distributed Windows PCs or like a number of targets that you want to connect to. And there's an abundance of ways to talk to them, right? You can do the connection in a million ways, I guess. Built in, not built in, protocols, etc. We're going to go into that later on a little bit. So the question for me was, how do I do that nicely and easily? And in the framework that we used previously before we migrated to DQMH, that was very simple to do, to have something that is generic, because the whole framework was built on string and variant being the data type of the messages. And I assume that you know you can do almost anything with a string. You can shoehorn it into anything you want. You can send it through a network. You can store it. You can read it from a file, whatever. So it was very flexible in that regard. And when I moved to DQMH, I wanted to have the same thing. So what I wanted is really, I wanted to have a module, a DQMH module, and we're going to talk about that in a second too. And I wanted to use that module and use it on both systems, both sides of the connection. So I wanted to use the same way of using the module, like of calling it, of sending it messages, of sending commands. I just wanted the commands to be executed somewhere else, right? But I didn't want to care about that. And also I'm going into that way more in the following slides. So, what is the agenda for this presentation? Introduction and code review, okay? Not so much, rather what I would appreciate would be some feedback. I know that this is difficult for people who have not used it yet, but then again, maybe you can share with me ideas on how this aligns or does not align with the things that you are actually using, or how you maybe could envision using this if it did X, Y, or Z. But there's a hidden agenda here, really. Of course, what I really want is to lure you into using DQMH and then falling for it. You know, every human can make a difference, right? So if I can find one new DQMH user here today, I'll be a happy puppy. Okay. By the way, if you have any questions or anything is unclear or my non-native speaking German accent is putting you off, please stop me right where I am and ask a question. Do not wait until the end. I much prefer to discuss the things while we're talking about them. Any questions so far? No. Okay. So if we talk about the DQMH generic modules, we need to talk about DQMH so you guys know what the framework is and what a module looks like and how we use it. And then we need to talk a little bit about networking. I think this presentation is not about networking, the technology, the paradigm, the protocol, or whatever you want to call it. And I'm going to give you a definition of what I mean when I say generic, because that's very important too, right? Because the nature of the modules is not easily understood, I think. I know Darren, who is sitting in the back, has been using them. And in the beginning, it was not 100% clear what I even wanted with that module, right? So that's very important, I think. Okay, let's start with DQMH. DQMH is the Delacor queued message handler. I alluded to that already. Delacor created this framework for LabVIEW. When I say framework, some of this is, by the way, borrowed from Darren's presentation, Introduction to DQMH. So some of the wording might be familiar to you, Darren, actually. When we say framework, we mean that we have a consumer-grade architecture, right? So something that is standardized, that is an architecture. It comes with documentation. It comes with tooling. And usually when you put so much effort into something, you are targeting not the smallest of applications. So maybe DQMH is not the best fit if a single VI will do. But we're going to talk about a few use cases. So you have to keep in mind that DQMH is targeting medium to large application development and also teamwork. So again, if you're in a silo, you're usually creating one VI, depending on the VI, I would say now, of course. A framework might or might not be a good fit for you guys. The DQMH, as the name gives away, is expanding on the NIQMH. It adds event-based messaging, we'll see that. We can run modules in parallel and we can start and stop them programmatically. Who is familiar with the NIQMH? Okay, very good. So that's good. We can cut some corners maybe. DQMH, the most important thing for us as the DQMH consortium who maintains and develops and furthers the DQMH framework is the developer experience. I think that's also important to say. DQMH might not be the most advanced, the most elegant, the best performing framework that is out there. But in my book, it is the framework that is the easiest and the most fun to use. So this is the focus for us, the person that's sitting in front of it. How difficult or how easy, how simple is it to get your job done using that framework? So this is the focus for us, the developer experience. That's why we put so much work into the scripting tools. That's why we have our API tester. That's why we have our validation tool and all these things that make your lives easier when you're getting your work done. It's free to use. That doesn't hurt, I guess. So you can download it and try it right away. No strings attached. We do have a commercial license if you want to purchase one. I think that happened once with a government organization. They could not go with the free software. Move. Okay. So, but that's just a side note. So usually you go to VIPM, you download, you start using it, you're happy. I'm going to skip over the history. I think that's too much information here. We already said Fab created it. Now we're a consortium. So the important points have been taken. What are use cases for DQMH? I think that's interesting to talk a little bit about. And again, I will appreciate feedback for these things. The first thing you get from a framework built on modules, surprise, surprise, is modular code. So you look at these pictures and you see, okay, there might be a power supply or a database. You want to provide a configuration file. You connect to the device or to the server. For the power supply, you might want to set the voltage or read back the current. For the database, we see here there's a query being sent, and a second query that actually has data coming back, a result set. So this, I think, these are very valid use cases for working with a DQMH module, using it like you as a developer would be the user of that module. The module provides functionality, and you have certain VIs that you can use to tell the module what to do. Are there any thoughts about that, using a DQMH module or a framework for that kind of job? Any ideas on that? One might argue that it might not be worth the effort, actually, because it would be very valid to say, I'm seeing 4 sub-VIs. I can do that without a framework. And that's very true. So while this is a valid use case for a DQMH module, depending on your specific application, you might get away or might have an easier life not using a framework. So the next thing that you can do with DQMH, you can implement parallel processes. And this, I think, is where you would have a much more difficult life if you were using an FGB or an object-oriented approach. Because look again at working with a database. We see we're providing a config file, we're executing a connect function, and then we want to enable a keep alive function. So in our projects, we had a SQL server that would close the connection after 90 minutes if there was no traffic. So we had to implement a process that would keep sending requests so the connection would stay open and it would not run into a timeout. So we need something that runs in parallel somewhere else that is not getting into the way of your program, but still it needs to be running somewhere and you want to stop it too, right? So if you're using an FGV, that third call here, this one, it would block your FGV or your VI or your class, right? Because it would stop here and it would keep like doing the keep alive loop. So that's fairly trivial if you have a framework that starts a parallel process anyhow. You can put your loop in there, it can run in parallel, and your code can move on executing. So modularity, and then we also have parallel processes. Starting and stopping, that's also quite nice. If you're familiar with the DQMH, what it does is it puts the QMH code on your block diagram, so you can run it, and then it stops. There's not an easy way to do that programmatically. Start it, stop it, on demand, whatever. So DQMH as a framework, the module starts when you tell it to start. That's the code for that. And it stops when you tell it to stop. So you can build that into your application and you can use it in any way that you see fit for the job that you need to get done. And then, of course, there's clones of a process. If you have multiple processes of the same type that you want to easily maintain and load, imagining you have a bunch of power supplies in your rack and you want to have modules, have software for 3 or 4 power supplies that are of the same type. With DQMH, you do not have to duplicate the code. You maintain your module once on disk, and it's of type clonable. So this is one of the 2 types of modules that you can create with DQMH. You can instantiate multiple clones of this module, as we're seeing right here. So we'll start 4 instances, and each of those 4 instances will get a different configuration file, might have a different IP address or COM port or whatever it is. Okay, so after we've talked about the use cases, maybe it's worth noting, so far you've only seen the VIs that you use to talk to the module, right? You have not seen the module itself, and that's what we're going to look at right now. So when you're talking to a module, what is a DQMH module? It's a LabVIEW library. Technically, it lives in your project. It's a LV-lib. It has a certain file structure, virtual folders, it has files inside. So that's one way to look at a DQMH module. Many times when you talk about the module, what we actually mean is the main VI. The main VI is the VI that actually contains all the code that executes whatever you want to implement, like your QMH. And then there's a lot of scaffolding around that. So sometimes when we talk about the module, what we actually mean is the main VI. That's the VI that is started and run asynchronously. So that's the process, if you will. And then also a DQMH module is an actor. Not now talking about an actor from the actor framework, from a nice actor framework, because an actor is a model in computer science. And I want to say that NI did not the best job calling their framework the actor framework.
Correct.
It should be the LabVIEW actor framework.
Yes.
No, it should be the actor framework for LabVIEW, because that's in the rules for naming.
Yep.
You should know that, Sergio, as an NI person. No, just joking. An actor has state, right? It's the master of its own state. An actor can receive messages. It can decide if it wants to react or not, mostly depending on the state. And by that definition, by that computer science definition, a DQMH module is an actor because it does have state. It can receive messages, it can react to them or not, and it can also send messages. So that's one way to look at a DQMH module. I've been talking about communication now a little bit before, and we've seen those VIs where I said, these are the VIs that you use to talk to your module. So what does that mean? You can send messages to your module. In DQMH, we call them requests. And the request can be asynchronous, non-blocking, which would mean you put the request VI on your block diagram, you send a message to the module, and you move on. You do not wait for a reply. You don't really care at this point if the module does anything, if it acts, if it does not act, if there's an error maybe. The asynchronous communication just sends the message and moves on. Opposed to that, we also have synchronous communication, of course, which is blocking. That's the request and wait for reply, as it's called in DQMH. And this one acts more like a sub-VI. So you have the request VI, you wire in some parameters maybe, and then that VI stops until the module sends back information. So when you remember before we saw the get current request from the power supply, that one obviously is blocking. Because the VI executes, I tell the module I want to know about the current, I'm waiting for the current value. When the module sends the current value back, the VI will return that value and move on. So this is the blocking kind of request. This is the way of synchronously communicating with your module. Now there's a very important third type of communication, and that is sending messages from inside a module to the rest of the world, which we call a broadcast. As it says down here, it's 1 to n, so one module can send broadcasts to as many recipients as have registered for that broadcast, hence the name, a broadcast. And that's very handy when you want to distribute status information about your module. We always use it for data acquisition when we say there's data acquisition going on, the acquired data is being broadcast, so many data sinks can make use of that data. So this is the message named broadcast in the DQMH module. What does it look like? Just quickly go through this. A project library, LV-lib, it has a certain folder structure inside the public API. The public API is the only part of the module that you meant to use outside of the module, hence the name public. And you can see here, there is no little red key icon on that folder, right? Whereas all the other resources in here are private. So the public API contains those VIs that we saw on the previous slides on the screenshots that you're supposed to use in your code. So coming back to the example of the power supply module, the module itself would contain the driver, the way that you talk to the module, maybe it would encapsulate all of that, so that you, as a user of the module, can happily use the get current VI, and you don't care if it's Ethernet or serial communication or whatever it is under the hood, right? That's all contained and wrapped in the module. Somebody took care of that, hopefully in a good way. and you're just using the module. And the only thing you need to do is you need to take the get current VI and drag it onto your block diagram. Very handy. We do have broadcasts in the module, as I said before. If you want to find them in the project window, they're in here. A little more scaffolding, like I said before, and then the main VI. So this is the place where it all happens. This is the place where the QMH is implemented. And then we have the API tester. This is a very, very important element of DQMH. Every module comes with an API tester, and you can see it lives outside the library, right? So it's not a member of the library, because what this guy does is it's supposed to use your module as you would in your application. So while you're developing your module, you can use the API tester to test what you're doing. So again, with the power supply, maybe you're using your power supply in a big application. You don't want to start your application anytime you want to test something. No, with DQMH, what you do is you run the API tester. You can start your module from the API tester. You can call all the public functions that you implemented from the API tester. And you can use it to test your module in isolation, do debugging, do anything you want with the module. And what that means is, or what that gives you is that when you arrive at the point where you say, I tested my module in isolation, it works well. When you then go on and integrate it into your application, and there are problems, you know where to start looking, right? It makes sense to look at the integration part. You don't necessarily need to look inside your module for any trouble that you get then. This comes with a disclaimer, the API tester. That's an ongoing joke that I keep making, but it's, you know, like with jokes, there's always some quantum of truth in it. Don't let Fab find you with an API tester that is not up to date and maintained. She will rip your head off.
That's good to know.
Fair warning.
It's semi-literal.
Yeah, it's, I wouldn't dare risk that.
Even worse than that,
Thanks for the warning.
Even worse, okay. So you've been warned, guys. Actually, that might be a downside to using the DQMH framework. We need to stop saying that.
What is the downside?
It's not a good marketing message that you are ripping heads off.
It is.
You know, one of my customers actually said that I was successful in packaging myself into LabVIEW.
You are.
Okay, so if you want a little dose of Fab, more digestible maybe, this is the way to go.
Yeah, he said that. At least this one doesn't yell at me.
Exactly. Okay. This is what a DQMH module looks like. And we are all aware that it's a lot, it's a handful. There's a lot of boilerplate code here. Once you get familiar with the framework, you learn to not bother with that, to ignore that actually, because you don't have to care about it. All of this is a template and prepared for you and scripted. So we need code to start the module, to create some resources, create some event references and whatnot. And then we have our QMH pattern, and then we have code to tear it down. And all of the things that you see here, all of that has been either provided by the template, or it has been coded, generated by the scripting. So nothing of what you're seeing here had to be taken care of by me, myself. I can just use that as it is. So the producer-consumer pattern, you said you're familiar with QMH, so probably you've heard about that design pattern. The idea of this is to have a place where events are caught or produced, and then you hand them on to the consumer. So there is a disconnect between where things are happening and where they're processed. So for example, for user interfaces, this is quite handy because then you keep your user interface interactive and reactive while you're processing some things that take longer, maybe. Of course, if the consumer cannot keep up with the producer, at some point you're running out of resources. But if it's like individual single things that take longer, that's a very good design pattern to do that. From the producer-consumer pattern, we add a queue, and we have our queued message handler. That's the name that I gave this little child. Does anybody know when the QMH was published? Do we have any idea?
2012, right, Darren? 2012.
2012, okay. 13 years in the making, still using it, so can't be all bad. In DQMH, we call the upper loop the event handling loop, because it literally does right that, it handles events. The lower loop is the message handling loop. So that's the one that processes the events that are coming in. We are receiving an event, we're sending it down the queue, we are processing the message in the message handling loop. And then for DQMH, we add the public API. So this is the way that you talk to your module. I said that before. We have the public API VIs. Those are the only things that you need to care as a user of a module. And as a developer, you know this is the place where all the requests from my module users are coming in. So I receive them here, I send them down the queue, and I process them down here. I was talking about parallel processes, so we are seeing a DQMH module again. We have the event handling loop, we have the message handling loop, and now we have a third loop, a helper loop. That is very handy. Many of our modules actually have one or more helper loops, because this loop can do stuff in parallel, like I said. So in this example, for a data acquisition module, what we can do here is we can have a third loop that actually takes care of the data acquisition itself. So you can see a loop, and you can see there is some kind of hardware abstraction layer, so there might be some DQMX function or whatever wrapped inside this little guy. And then we're using a broadcast to share the acquired data with the rest of the application. So you can see here a little satellite icon. So this tells me, oh, okay, this is a broadcast VI. This is where data is actually leaving the module. And for anybody who registered for that broadcast, they will receive that. And you can see the beauty in that. There's so much beauty in that, actually. Because first of all, the way that NI implemented the whole event system is very nice to be used. Once you wrap your head around what it does, it gives you a lot of flexibility. So where we are generating the module, where we are generating the broadcast, we don't really need to think about if there are any listeners at all or many listeners, because the event queue that takes data to the sink is created at the place where you register for the broadcast. So every recipient is responsible for their own event queue. When they register, they open it up. When they unregister, they close it down. So whether there are 0 or many recipients, we don't care. There is no memory leak, no nothing. So as opposed to a queue, where if you put something in the queue, you need to take it out. For the events, it's kind of abstracted away in a way that makes it very easy to use for the recipients of the broadcast events. And then the other handy thing is that timing usually comes from the hardware, right? So if you're using DQMX, you probably have a sample rate and a block size, and then you have that equidistant deterministic acquisition. So let's say we acquire with 1 kilohertz and we want to have 100 sample packages. That means that this loop will execute 10 times a second. The broadcast will be executed and sent 10 times a second. So any recipient will also receive that timing. So if you want to do something timed with the data, the broadcast forwards the timing to your recipients. There was a question.
Will you get a warning or an error if there's no one registered for your broadcast event?
The question was if we get a warning or an error if nobody's registered for the broadcast. No, we do not. And I will argue that this is the nice thing, because this module does not care. It's not this module's job to care if anybody's listening to the data, right? The job of this module is to do the acquisition, provide the data. So if you need the data somewhere else, that would be the place where we would have to take care that you're doing something with the data. If nobody is registered, no harm, no foul, it would just not be distributed. This module, of course, I mean, we all know we can do anything with LabVIEW. So of course we can implement whatever we want on top of what we have right here. So you could have a registration here in some way that says, I know who is registered. I know the IDs of those modules, the names, all of that is possible. But the framework itself gives you the mechanism of providing the data and not caring who is listening. So that's the default. Okay. Thanks for the question. Moving on, how do we create a DQMH module? Sorry, I need to be a little cautious of my time. How do we create a module? That's very easy. We're going to the tools menu. We're saying tools, DQMH consortium, DQMH module, add new DQMH module. We get a nice little window where we can type in the name of the module. We can select the path. We can add a description that will be in the documentation if you choose to create one. A few more things. The type of the module, it can be a singleton, which you can only start and instantiate once. Or it can be a clonable, where we saw you can instantiate multiple of these processes to run in parallel. Depending on your architecture, you might choose either one or the other. And then you can edit the icon for the library, right? So when you create your module, it already has the nice icons with the name and the color on it. I suggest to do that right away. Then you say, OK. Then LabVIEW does something which usually takes quite a long time. So it copies files, it moves stuff, it renames stuff, it updates the icons, it changes some names. And finally, you arrive at this new module in your project.
It will take you a lot longer to do it manually. I'm just pointing that out.
Thank you. So what the framework does for you, if you did that manually, probably it would take longer than the computer takes to do it. So that's good. Still, when you're doing it the first time, you might be thinking what's going on. It takes like 15, 20 seconds, however fast your computer is. So it's not instantaneous, is what I'm saying. What we get from it is a lot though. And again, we have the LVLib and we have the API tester. Okay, any questions regarding DQMH so far? So far, so good. Okie dokie. So let's talk a little bit about networking, or rather not, actually. I hope that this will work. I try it every time. I have a 50-50 success rate, to be honest. So can you try and go to that page and type in that code? And see if you arrive at a page that asks you a few words that come to your mind when you think about networking. So just what do you think about when you hear the word networking? What's what you come up with? Okay, would you type it in? Let's spend like 60 seconds on this. It makes for a nice word cloud once the replies come in. Makes for a good LinkedIn post later on for me, so I appreciate you all. Perfect. The last time I did it, there was only the word networking, and the question was enter a word, so there were all sorts of random weird words there, nothing about networking. So this is working very great. You're a very great audience. Thank you for that.
You want me to start with the no?
I'm good, thank you. Okay, so we're seeing communication that is key, as always, not only networking. We see some protocols, we're seeing some architecture things, connectivity, transfer, not reliable, which is not a good thing. Some people did not read all that is on the slide. Think about computers not hooking up, so beer, I'm not sure. Anyhow, thanks for doing that, for humoring me. This just goes to show that there is a lot of stuff that we can talk about when we're talking about networking, and this is not the forum for talking about networking. Just make sure to understand that there are lots of network architectures out there, and the DQMH Generic Networking Module is implementing one of these. It's usually a client-server scenario. So you can make your module a server. That means that other modules can connect to it, or you can make your module a client, which means you want to connect to another module. So these are the two roles that are implemented in the generic networking modules. Going back to the original problem statement, I have a computer and a target, or maybe multiple targets, and I want those two to talk to each other. So this is the mechanism, this is the architecture that we had in mind when we started creating these modules. We can talk a little bit about networking later on, about the protocols if you want to, but I'll try to walk you through what the modules are before we do that. Last thing, generic. What do I mean when I say that? The generic networking feature, in my mind, it should be a native citizen of the network, of the framework, sorry. So it should come with the framework. It should not be user code that you need to implement. It should be easy for the user, for the developer to use it, to do it. Not necessarily to implement, but then you as a user of the module, it should be easy for you guys to use the module in an intended way. Maybe even transparent to you guys. So just being a configuration to tell it, now you're networking, now you're not. The HSE DQMH GenNet should work with any custom-made DQMH modules, mine as well as yours. I only want to use the public API of the module, no matter where I am, no matter where I'm talking to. And I want to be able to configure that at runtime. So looking at the module again, we have the public API, we have the event handling loop, which receives the events, which receives the requests. And then we have the message handling loop, which processes which does the actual work. So what I want to do is I want to cut that in half. So I want part of it to run on the real-time side in this example, and part of it on the Windows side. So in the example that I'm making here is we had a project where we had a database where we did not have real-time drivers for that. It was a MS SQL database that we needed to connect to from our single board RIOs, if I remember correctly. So we couldn't do that natively on the single board RIO. So what we came up with was we already had a Windows host, so we said, you know what? The RIO talks to the Windows computer. The Windows computer does the actual SQL queries and then sends the data back to the RIO. So exactly like we said before, the request with reply. I want to have a request that says execute query. I wire in the query I want to have, and then I want to receive back the data. just that in this case, in this scenario, it is tunneled through a network call. So what are we doing? We are starting 2 more DQMH modules actually. One is the GenNet client and one is the GenNet server. So that already gives away what we're doing here. The server is running on the Windows side. The server has all the code that we need to execute the actual queries. So here would be the database connection. And then on the client side, we would open a connection to the server. So this client is connecting to this server, and then we are routing the request through, right? So the event is sent on the real-time system in our example. It is received in the module running on the real-time in the event handling loop. But now the queue message is not going to this message handling loop, but instead we're sending it to the module, we're forwarding it to the GenNet server, and we are injecting it into the message handling loop that's running on the Windows side. So here we can perfectly well execute the SQL function, like I said, request some data, send back the reply, and send it back to whoever was calling the request in the first place. So that's the idea, the original initial idea of the DQMH generic networking modules, to have one module, the same, literally the same code, that's running in 2 systems. On one side, I'm using the public API. On the other side, I'm executing the code that's in the message handling loop. Does that make sense so far? Awesome. Any questions? No, good. So, put on your thinking caps now, because this is the tricky part. This is the ugly part. This is the part where I think so far we're in agreement that the idea is good. I want to use the public API on one side, I want it executed on the other side. That's nice. For the implementation, I had to jump through some hoops. First of all, what do you need if you want to use it? The documentation and the source code, I already alluded to that before, so that's available for you guys later on maybe. And how do you make your DQMH module GenNet enabled? So what did we do? The first thing that we did is we did override the message queue. So inside the DQMH module again, if you've seen one before, there is a message queue. So this is the queue, this is actually it's a class that wraps the queue reference. Messages are being sent down here. For those of you familiar with the framework, usually these are light blue, Delacor color. And you can see for HSE, for my company, everything is purple. So we changed the color to purple. And why did we override the message queue? Because in the dequeuing, in the message dequeue VI, this is where we decide if we want to process the message locally in this module, or if we want to reroute it through the network. What does it look like? It's quite simple actually. So the regular dequeue message VI looks like this. And what we added is a Boolean sent via network. And if this Boolean is true and the blacklist, the message is not in the blacklist, we're gonna reroute. So instead of returning the message out here, we will call a specific case which is called send via network. And that specific case in the message handling loop contains the code to forward through the network. So that's built into the DQMH generic networking module. You don't need to worry about that. If you wanted to retrofit one of your modules, these would be the steps that you need to take to make like a vanilla module into a generic networking module.
So what's in your false case here? You just do the database.
That would just be the straight wire through, because what this VI originally does is it takes the message from the queue that is coming from the event handling loop, and it decides which case to execute. So if I go back one step, normally, this is what happens. You dequeue the message that's coming from up here, and you're just executing that case, right? So that's the regular behavior. And in the case that you want to forward it, instead of returning that value in here, we're instead saying send via network, and we are adding the original message name as a variant attribute. So the receiving side can like unpack it and then act on it. We'll see that in a second. So either it's just default in the false case, and in the true case, go to the special send via network case and do your thing. Of course, if the module wants to be a client or a server, there needs to be code that actually does that, start a client or start a server. So there are VIs for that. If you want to retrofit your module to be a GenNet module, you need to add that code. There's a VI here that does that. Same for the server side. So inside these two sub-VIs here that we see, That's basically where we are starting those helper modules that we saw in the previous screenshot, like the GenNet client or the GenNet server. Starting that, handing over some network configuration, and then setting up the infrastructure for that. So far, all good. Now it becomes more painful. We need to slightly change the way that requests are handled in the framework. The way that it works right now is that when we have a request with a reply, so the synchronous messaging paradigm, the reply is sent through an additional resource and notifier, and that notifier again has a certain data type. And that data type is specific to each single message. What that means is that each single reply message probably has different data in it, right? For the get current, you wanted like a numeric value. If I had a gate status, it might be a cluster of Booleans or whatever it is. So each module's request reply message has a specific data type. That's not generic, right? That's the opposite. That's specific. So how do you route that through a system? The only way that I could find was to change it to make the notifier reference a variant and handling that variant, because a variant is generic. It can contain anything we want. And that's what we need to do in this place here. So for those of you who are not so familiar with DQMH, usually you would see the notifier reference here, and that would have a strong data type. Like, for example, a cluster containing that one numeric value for get current. We wrapped it in a variant, add the variant here. We need to unpack that notifier reference in a slightly different way. And we need to also then wrap the reply data into a variant again. So you see, we need to add this VI, that VI, and that VI. 3 places where we need to touch our DQMH module if we want this message to be possible to be sent through the network in that generic way. Now, it's not like we can't do that, but it's work. So it's not ideal. Again, I couldn't find another way to do that. I keep arguing that the reply message should not be on the framework level, but that ship has sailed for me. DQMH is what it is, and my feature request did not get enough kudos so far.
And you don't have a veto power.
Yeah, it's a big change. So it wouldn't be possible to do that backwards compatible. So one thing that we do whenever we release a new framework version of DQMH, we make sure that it's both backwards compatible and that we have an upgrade tool that changes all the code for you so that it matches the style and the requirements of the latest version. This would be one step too far for that. So the problem is it doesn't stop here. So far that was okay, I think. We can deal with that. But of course, in order for that notifier that comes in to be of type variant, we need to change it where we create it. And where we create it is the actual request VI. So bear in mind that a request VI is generated through the framework, through the scripting. You usually don't really look at the block diagram. Again, there's a lot of boilerplate code. This is what the insides of such a, for example, execute query VI look like. And you can see that there are stuff, timeout, whatever. This is the VI that actually sends the event to the module. And part of the payload is the notifier reference. So we need to change the notifier to be of type variant. That's what I'm doing here. And then over here, where we receive the notification with the data, we need to convert the variant back into the original payload that we sent. All of that is a pain, I'm aware of that. Yes, please.
Couldn't this be an option when you're creating the module to different this type?
You want to use the, sorry.
Couldn't this be an option when you're creating a new DQMH module to just like you have the clonable versus the
Singleton?
singleton, thank you.
Yeah.
The same way to kick this off in a different way.
Very good question, thank you. So the question was basically, could we make a template for that, a DQMH template that you can select from your drop-down when you're creating a new module? Some of this you can prepare, but for each request that you then add after that, that request would be created in the traditional, in the vanilla way that DQMH works. So every new request that you add, again, you would have to jump through those hoops. I'm going to answer for you. With the latest version of DQMH, we have a feature that is called scripting hooks. So you can create your own automation on top of whatever DQMH does. So I could go and sit down and say, I will create a plugin. When DQMH creates a new request, my code starts goes to these places and does these changes automatically. So that would be possible. Template would prepare the general setup, like the start server or start client that we could do there. And then for every request that we add, we now have the technical means to do the scripting automatically. That was not there like whenever I created these modules, and it's a lot of work. So one of the questions I'm asking myself is it worth it? Because how often do you do that? How many requests do you add to your module in your project? Is it 5? Is it 7? It takes a few dozen hours to implement the scripting probably. So that's one of the questions I'm asking myself. How much pain is it versus how much effort would it be to do that? But yes, there are options that we have for that. Okay. We have these places. And then for the networking architecture, like I said, what we do is we have a client module or a server helper module. And what we are sending, the abstraction layer, if you will, we call it a protocol. I'm not sure it was the best name to pick when I did it, but it is what it is again. Protocol not only means the actual network protocol, but also the syntax of the messages that you're sending. So the original protocol, the variant protocol, is just taking the message variant as it pops out of the DQMH message queue, take that, shift it through the network and extract it on the other side. So that's what we call the variant protocol. And then for one of our customers, we also implemented a plain string protocol. So this is working slightly different in that the message on the network is actually a human readable plain string, because they wanted to use the same mechanism, but they wanted to be able to send messages from Simulink, actually. And in Simulink, it's not nice to try to rebuild the data structure of a LabVIEW variant, of course, but they can perfectly well generate strings, send those through the network, and the receiving side, the server, is then able to process those strings as if they came from a DQMH module. So this is one way to open this mechanism up to be open to whatever you want, as long as you find a way for these two sides, a contract, if you will, to communicate with each other. And string, obviously, is one of the simplest things that you can do. So just as an example, for the variant protocol, when we wait for a connection, this is just how you would usually do it. You have a listener, you're waiting for incoming connections. If a client connects, you get a connection ID, so you go and you spawn a parallel process that caters to that one client, and the server goes back, starts listening again if a second, third, fourth module would like to connect. So technically, the architecture allows for multiple clients. Of course, it depends a little bit on your application. If on the application layer, that would bring problems or not. But the underlying architecture supports that. And then for reading and writing, it's again trivial. There's a TCP message, a string that's being sent. It's just the variant flattened to string, the size appended. And then for the reading, we read the first 4 bytes. We know how much more to read. We convert that back from string to variant, and we're good to go. So I think very simple, very trivial. Yes, please.
Are you building the networking on TCP directly with these VIs, or is this all using the broadcast feature of DQMH or something else?
Yeah, very good question. What we're seeing here is the bottom layer, if you will, of sending a message and getting a reply. So this is the implementation, how a request gets from the client to the server. So far we have not had any broadcasts in the whole equation here, right? So this is only for the request side of things. So if you're sending a message to the module and want a reply for that, that's that part. That's in TCP for this protocol, for the variant protocol. And for the broadcast, we actually do use UDP because that allows us to multicast, which is more or less, well, it's a similar thing, let's put it like that. So the broadcast of a module from the server side, those broadcasts will be amplified and forwarded through a UDP multicast message that then again, any number of modules can subscribe to. Okay. Yes?
So in the case of a clonable model, sorry. Thank you. So in the case of a clonable model, you just need these only, like, for example, the GenNets server, you just one, or do you need that one to be several instances of it?
So the modules that are being GenNet enabled are always singletons, I want to say. I don't think we've ever done a clonable. But the GenNet server and the GenNet client, they are clonables because we can have more than one module that wants to talk through network. Usually we do have that. We have a control connection, we have a data connection. So we will, in our application, we will have more modules that are using the network feature, but they are singletons. And going back here, these modules are usually singleton, but these are clonables so that more than one singleton can do the networking and leveraging these clones down here. Okay. Another question, Ravi. Quick.
So I don't know if this is the right point in the presentation to ask this, but what's the benefit of doing it this way versus keeping the EHL and MHL on both Linux and Windows? But in your MHL, let's say on Linux, you want to send a message to Windows. In your MHL, you actually implement your own protocol, whether shared variables, TCP, whatever. And then can't you just have an entry point on the EHL on Windows side and do it that way? And that way you don't have to touch the DQMH underlying. Like, what's the value add of doing this over that?
The original idea for the value add was you would not have to touch anything, but you would instantiate a module that is that's GenNet enabled. So you would not have to implement these endpoints by yourself. But this is just another way to do it. So if you choose to implement the endpoints, or you create a specific communication module for your project where you implement all those messages, all these things are more or less equivalent to this. This concept here allows you to maintain a single module, and you run it on both sides, and you can at runtime decide what you want to do. So I think it gives you more flexibility and more transparency to the user, because if I create the module, you as a user, you don't have to worry about anything at all. The module just looks the way it always looks. You don't even see the networking code in your module, so you're not distracted. You just tell the module, you be a client or you be a server now, and it does that, right? So I think that's an advantage if you look at it from that point of view. So you just use the same API, public API VIs, the request that you would use anyhow. So whether you're programming your database for your Windows application, or then for the next project you move on to have a distributed system, nothing would change from your point of view as being the user. You wouldn't have to care about that.
So when you talk about making changes to the DQMH architecture, that's something that you did or your company did. That's not something that we would have to do necessarily, like all the...
So if we were to go at the extra length of creating those scripting functions to augment our modules, that would be part of our open source offering, definitely.
But this is already open source.
I mean, this is already open source, so you can go and use it. At the moment, like we said before, I have to change those request calls manually. Again, for us, that's not a big pain point because, first of all, we have done it a few times, and then there are only so many requests that you want to change. I do understand that for new users, it is an uphill battle.
I was going to say it's an open source project, so you can always open a GitHub or GitLab issue. And if it comes with a bill of maybe, I don't know, a couple $100 with your sign name on the back, I'm sure they would implement the scripting thing.
Thank you very much. A very good pitch. I'm looking for input. I'm looking for the good questions that say, well, what are you doing there? Of course, contributions are welcome. We have implemented stuff for our customers based on this. Like I said, the plain string extension was a paid-for project for us, even though it's now part of the open source project. Our customer didn't care sharing it, they just wanted it. So that's also maybe a way that we can further this project.
So since this is UDP, is there any network status information? Is there a heartbeat sent back and forth to know that your connection's still there?
So the request side of things is TCP. So if you send a request from the client to the server and the reply, that's going through a TCP connection. So if the connection breaks, we try to connect again. There is not a heartbeat. That would be something from my point of view, that would be something on the application layer. So in your module, of course, you can implement a repeating message and that would tell you what's up. For the UDP part, that's completely transparent. So the module sends the UDP broadcast. Like technically, we don't know if anybody receives it on a network level. So that's the again, adhering to the DQMH paradigm of the broadcast. Server broadcasts, if anybody listens, if they can receive it or not, the server does not care much. Sometimes that's a pain because UDP, the way it is routed through company networks, that might be challenging or not possible at all. But that's part of the solution as it is right now.
Thank you. Here's a follow-up question. So,
Well, UDP is inherently lossy, right? So I guess the question is there any mitigation for that or any way to know that each endpoint got the message?
A very good question, thank you. Question was, UDP is designed to be not connection oriented, so it can be lossy because you have no way of telling if you received all the messages. There is no way at all, neither in the GenNet or in any of our projects that we usually do, to mitigate for that. Again, to me, that is an application level problem because if you think about it, the same thing applies to TCP. It might be that the protocol takes care of that connection-oriented status, but on your application level, you still have to check if there was an error and if the data makes sense. And I think if we needed that certainty in an application, maybe that would not be a broadcast in the first place. That would probably be turning around the connection and saying, I'm giving you dedicated data one by one. But for like updating your UI, that's the number one reason to use the broadcasts, or like telling where in your test sequence you are for these things. We're using the broadcast. And we're also using it for data to be displayed and logged, now that I think of it. So that the data acquisition example I showed before, that would be a UDP broadcast. And we would assume, I have to say, probably, technically, that all the data is there. But I think the problem would not be on a network level, the problem would be on an application level. If like the LabVIEW program is at 100% CPU, and then it does not keep up. I have not seen like UDP packages being dropped, actually. I've never seen that. And I've done a lot of network work. So the protocol level was never a problem so far. So, another question.
If you need to configure the UDP connection, like there are cases in which I think UDP ports might be blocked or something, how do you configure it? How do you change it?
So all the connection details are in the configuration, first of all, so you can choose whatever port you want to use. So if you know that your IT department opened port 7, 8, 9, 12, whatever, you can configure that. Other than that, you would have to talk to your IT department if that's a concern. Usually when we're talking about UDP broadcasts, they are by definition not necessarily forwarded through routers. So it would be in a local subnet, usually. And in that scenario, that's a use case where probably no ports are being blocked. But if it does not work, it's worth talking to your IT department to figure out, is there a network switch, a managed network switch in between or something like that, that keeps you from receiving data. Also, of course, on your Windows system, the Windows firewall might not be happy with your application receiving data on some network ports. So that's another thing to look into. So when we are setting up a new system, we always disable all the security mechanisms and make it work. And then we go backwards and make it safe again, as safe as is possible, because this is not like encrypted or anything, right? So that's another thing to point out. The current implementations we have, plain TCP, no authentication, no encryption, no nothing. So it's good for us. It's okay for the places where we use it. It's not living up to the standards of a publicly distributed system, of course. So I think I've talked to all the slides. I haven't shown them. If anybody wants a live demo, please come find me. I don't think there's time now. You're going to see the exact same thing that you saw on the slides. But I'm happy to show you all around. There are some resources here. So if you're interested in learning more, take a picture of the slide, please. Or again, come find me. I'm all over the place, so you should be able to find me somewhere. And come talk to me. I would like that. Thank you very much.